What's up guys, welcome to June Electronics. My name is Clément, and today we're gonna be talking about RGB LED, how to calculate the right value of the resistance for you to be able to power the LED without burning it. I'm gonna go ahead on the board there, and I'm gonna draw it simple circuit, and then try to calculate the right value using Ohm's law. And so I won't say much here. Rather, I'm gonna go ahead and show you on the board how to go all about it.
Take this one here. Okay, so as you can see, it's 5mm RGB LED common cathode. Okay, then so we have the color is the red, green, and blue. But what is important for us is to know is on here, this data sheet here. Specifically this here, this. Okay, so these are forward voltage. Okay, so we have a red is about 1.9 volt. It's actually 2 volt. This is the minimum, then maximum 2.5. Beyond that will burn out. And then we have here green 2.9 and the blue 2.9 as well. Beyond that 3.5 the maximum. Beyond that will burn the LED, and it's about 20 milliamps. Okay, so this is the information we need to calculate the right value for the right value of the resistance to power the LED. So this is the most important information.
So as you can see here, we have RGB LED and Ohm's law. Okay, so we're gonna be working with these two things here. So the first thing that you see here, this RGB have a meaning. The first one itself is red, and the second one it is green. The third one is blue. Okay, that's the meaning of RGB. Okay, so I'm gonna show you an LED here. Okay, this is an RGB LED. So as you can see, it is one LED with the 4 pins. So the one pin here you see is longer than the other one. So the longer pin is the minus of that is the cathode, and the short one is the anode of the positive. Okay, so what you see here, I'm going to draw it there so that you have a nice visual about it. So this is going to go like this. Okay, so this is the 3 LED. We have the red, green, and blue. The longer side here, this is the cathode here. This is the minus, and the other side anode is a positive. Okay, so let's say we're gonna power this LEDs on with 5 volt. 5 volt. Okay, if I connect this thing directly like that, this is wrong. Okay, because 5 volt, as we have seen on the data sheet, the LEDs have their own voltage, or they can start working from the certain voltage to certain voltage. For example, here we have seen the first LED here. It's about 2 volt under to 0.02. Okay, let's say it's 2 volt under 0.02 milliamps. Okay, this is the first LED, which is the red one. The second one is 3 volt under 0.02 milliamps, and the third one here is also likewise 3 volt and 0.02 milliamps. Okay, so if I power this LED with 5 volt, of course, then we see we're gonna burn the LED here, and we power the same, we're gonna also burn the LEDs here. So we need to introduce here a component which we call it a resistance. Okay. Okay, so there's a 5 volt here, we have the resistance here, we have the LEDs here, and this is the minus side. Okay, so as we see here, we have values. Okay, we have the values, and this value is going to help us to calculate the resistance here to power these LEDs on. Okay, so how to go about this? You're going to use Ohm's law here. Okay, Ohm's law. And this is going to be a triangle, like so, divide, like so. We have the first one is volt, this here we have a current, and this side we have the resistance. Okay, so volt, okay, and this here we have a current. Okay, and then here we have the resistance. Let me draw it here. The resistance over there. Okay, so now how to calculate this? For example, we're going to put a question mark here. So we're going to be searching for these numbers here. Okay, and this here we know is the resistance. Okay, that's this one here. So if we cover now like this, the R we cover like this, we are left with voltage divided by current. Going like this is going from up to down is divide, from going to the left to the right is times. Okay, so I'm gonna write the equation like this. So let's say we're gonna start by looking for volt. Let's say here volt. Okay, we're going to be looking for volt. So if we cover the volt here, we are left here with current times the resistance. Okay, so this equation here is for finding the voltage. The second one here is going to be now the current. Okay, the current. So if we cover the current like this, we are left with voltage divided by R, this is the resistance. So voltage divided by R. Okay, and gonna give us something. Anyway, so this is the equation for that, and then we are now left with the resistance itself. The resistance. So we cover the resistance like this. We are left with a voltage divided by current. Okay, so this is the three method how to know about the triangle there, the Ohm's law. Now back to our circuit here, we need to calculate the resistance here, the right value of the resistor to power the LED. Okay, so we're gonna be looking for the resistance. Okay, we're gonna be looking for the resistance. That means it's a voltage divided by current. Okay, so if we go now ahead here and say 5 volt, 5 volt divided by 0.02 milliamps. This equation here is wrong. Why? Because we already know that the LED here uses 2 volt. So the right equation here is gonna be rather 5 volt divided by 2 volt. Subtract the 2 volt. Sorry. Okay, 2 volt give us 3 volt. Okay, so we now 3 volt divided by the current here is 0.02 milliamps. 0.02 milliamps. Okay, and this gonna, if 3 volt divided by 0.02 milliamps gonna give us 150 ohms. Okay, so this equation here, this value you find here is for 150 ohms. It goes for the first LED, which is going to be the red LED. Okay, like so. So the value here is 150 ohm. Now I'm gonna do the same equation again using this one here. You're gonna say 5 volt subtract now it is 3 volt. Okay, this LED is 3 volt, so 3 volt give us 2 volt divided by 0.02 milliamps, and thus give us 100 ohms. Okay, this value here goes here 100 ohms. Okay, the third one is the same it's the same method. Okay, same value. Again, we're gonna do the same. It's 5 volt, subtract 3 volt, that's D here, and this gives us 2 volt divided by 0.02 milliamps, and this gives us 100 ohms. So 100 ohms is correct answer for powering to power the LEDs without burning them. So this is a way to calculate the values of the resistance. This is a very simple explanation, but you can use this. You're gonna use you're gonna use the Ohm's law in many other circuits as you go on, or as you practice more in with the electronics stuff. Okay, so we have find the values now of these LEDs there. So this is all about it.